All right, so we've got some makeup work to do. We didn't meet Monday because of power outage and everything, internet outage, all that kind of stuff. But we've got, I'll cover some of that same kind of content. If you want to see more of it, then there is a video from last year that covers probably more than we'll be able to go into today. Maybe not. Maybe it'll be similar anyway. But I do have a couple of things I want to do today. First, we've got the printer back here. It looks different. We actually had a little ordeal there. This was a good example of what could happen when you don't think too far ahead. So what I did is I put on the Micro Swiss hot end, but you'll notice all of this stuff. This is not part of it. So I don't know if I still even have it handy to show you. I do have it somewhere. I just don't see it right now. Let me see. Well, the original cover here where the fans are mounted will not fit with this version of the Micro Swiss. So this Micro Swiss is an older one, and it goes for an Ender 3, but it goes with the older style Ender 3, and they had a different fan cover here. And this is a V2, so it had a injection molded fan cover that's a different shape. And anyway, that doesn't fit on there. So I had to print out a new one. So this part here, well, this is just a fan cover so that you don't have the fan blades just sitting there. It'd be easy to accidentally drop something in there and break off one of the blades, and then you have to replace the fan and all that kind of stuff. So all of that had to be printed, and so that would have been a problem if I didn't have another printer. So you do, if you have one printer, then you do have to think ahead and make sure that you're not going to have to print some parts to do whatever upgrade you're doing if you're disabling the part that prints. So I printed this. This is PETG. I think it might be I don't think it's a carbon fiber PETG. I think it's just a PETG that's black. And I printed it on a Kaiwu that's, you can't see it, it's back in the back, kind of over there. Actually, you might can see the corner of it. But it's just there was a really good sale on those larger Kaiwu, I can't remember what it's called, Max maybe. And they were clearing, this was around Christmas time this past year, somewhere in that time frame, and they were clearing them out for, I don't know, 20% of the normal price or whatever. So I bought one, and it works actually really well. They've since gone back up on the price. I don't know, maybe they just had excess inventory they needed to clear out. But anyway, I printed this replacement piece on there. So now, also in the middle of a print, the Creality Sonic Pad decided that it was time for an update. So it started to download. I guess it didn't download the update, but it triggered a message on the screen. And part of that process, I don't know what happened, but I think what probably happened is the update on here changed something that did not interact well with the older firmware, older now because of the update, older firmware that was on the printer. And so I had to start from scratch. So I had to redo everything on the printer. That's a good, if you are running Clipper, that is a good motivation to go and get your printer config file so you don't have to redo everything. I had to redo the PID too. I had to redo the PID anyway because this is a totally different hot end. This is an all metal hot end, so we can print up to probably 290, 300 degrees or so. At some point, the next limit on temperature isn't the hardware. It's, well, I guess it's a piece of the hardware. It's the thermistor that is measuring the temperature. So the thermistors that are being used here typically become non-linear around 300 degrees Fahrenheit, and they don't predict temperature or don't measure temperature very well. So if we wanted to go even hotter than 300, which is not really something this printer needs to do, but if you did want to build a printer that could go higher, then you have to start looking at, well, how am I going to measure that temperature? And so you have to look at a different thermistor, maybe a thermocouple. And so you have to change some other stuff. But now we can print again. I redid the PID mainly because I changed the hot end entirely, so it did have to be redone. It has the same nozzle that was on there before, so it's the 0.6 millimeter hardened steel. It is a direct drive now, so you might can see if I get the camera up a little bit. Yeah, there it is. I can see the old stepper. This stepper was sitting back here for the feeder. Now it's sitting directly on top of the hot end. There's maybe like, I don't know, maybe an inch. There's an inch of a tube here that between the feeding, well, between these gears and where it comes out is, 3 inches or so. So you have much less spring energy stored in any filament in a tube like this. I did leave this tube on here, but this doesn't do anything. This is just more guiding the filament into the hot end. It actually feeds from right here, so it pushes from here out of the nozzle. So there's a very, very short path for filament. And so that also means I need to change retraction settings. So I had to change those in Cura. Now it's at like a millimeter, or maybe it's half a millimeter of retraction, and drop the speed way down to 35 millimeters per second or so. Had to do that. Re-level the bed and everything. It does have the Pro bed sensor on there, so I had to go through a whole process. Partly because I changed to a direct drive system here, but also because I did not save the config file for Clipper and I had to rebuild most of it. So that took a while, but it's back printing now. I did one thing that I had not done before on Clipper, at least on the stream. I'd done it before, just not on the stream. And that is I went in and printed this. Now it's broken all to pieces right now. That's another story. But I printed this little guy. And this is a test model for pressure advance. So Clipper does pressure advance. You might have heard it called linear advance. The idea here, and I think I did talk about the idea before, the idea is that there will be pressure built up even in a short path like we have on the printer now. There will be some short pressure built up in the filament, and when you create a new layer, turn a corner, change acceleration, well, anything with the print. So like in here where these corners, I have to change direction. Anytime you do something like that, then that pressure the pressure inside the filament will cause bulges. And the idea with pressure advance is to know that, hey, we're about to do something that causes the print head to stay in a place a millisecond longer than it normally would if you were just going in a straight line. Maybe a couple of milliseconds. I don't know the actual timing, but a short amount of time. And if I don't take into account the fact that there's pressure going to force extra filament out, then I'll get bulges, particularly at corners or around transitions. And so pressure advance goes in and it tries to account for that. So you can get sharper corners without bulges on them. So this is a standard model for detecting that. And what it does, this one works with Clipper, and basically it starts at a low pressure advance and gradually increases the amount of pressure advance as it builds the part up taller. And then you read the part by trying to figure out, well, that corner doesn't look so good up here, but down in here it looks pretty sharp. Here it's kind of rounded. So you find where is it sharpest on all four corners, and based on the distance from the bottom of the print to wherever you think the best corners are, you do a little bit of math, basically just multiply by, in this case, 0.005 times how many millimeters it is from the bottom to that corner, and that is your pressure advance value. And so it can use that value whenever it's printing a part and it knows that there's some kind of corner or transition or something like that, and you're wanting to sharpen that up. So I actually set that on here. It doesn't take very long. Most of it's automated. You do have to follow a couple of commands that you can cut and paste into Clipper to get it to vary the pressure advance from 0 by increments of 0.005 in this case up to wherever. I stopped the print earlier because I was already noticing, you know, here it's so much pressure advanced that there's actually gaps in here, so it's shutting off way too early. So that's definitely not going to work. And so I shut it off. It actually prints this is maybe only halfway of what it will print. And you want to use the lowest pressure advance value that you can that makes sense. And so there was no reason to continue to print. Now this thing is brittle. See, it's super brittle. This is an effect of, this is older PLA that I have just sitting around. And that can be solved, I think, with drying the filament. So this filament has sat around long enough that it has absorbed some moisture from the air, and now it'll print, and it prints actually quite well, but the parts have no layer adhesion. Like, there's just nothing holding the layers together really. So I'm going to throw that filament in our dryer, the one I showed last time, the little Sunlu dryer. That it works pretty well for PLA. Other materials, it can't get hot enough to really do much for other materials, but it does work fine for PLA. And I'll throw it in there and see if we can print some parts that aren't disintegrating on us. And we'll come back to that. I do have one thing I want to show you. Let me see where I put it. Here it is. All right. If you live in a very humid place, or if you print materials that are, you know, they're going to absorb moisture more rapidly. So if you print ABS for some reason, or if you print nylon, or it's just really humid where you are, then you do need some way to keep your filament dry. And this works pretty well. So this is a little vacuum kit. Let me show you. I'll open it up, but I vacuum sealed a little roll of TPU last year during this stream, and I gotta go get it, but it's over here. So I vacuum sealed this a year ago. This is one of the bags that comes with it. It comes with, I don't remember how many bags, 6 or 7 bags. I'll have to see. I don't see. They're reusable. It's got a little port on it and a little hand-powered vacuum pump, basically, syringe style vacuum pump. And you pump the air out, and and you can throw some desiccant in there, a little desiccant pack. This has stayed sealed for a year, so it does seem to work pretty well. The content, and it's not very. It's like, I don't know, maybe $20 for the whole kit. There's a little vacuum pump. It has some desiccant packs. These you can get all sorts of these on Amazon or whatever, just to throw in there. And it's got several of the little bags, and it'll fit an entire roll. You don't have to despool it to, you know, something like this, where this is just a sample I had and I was trying out the bag. But it'll fit an entire roll. Just one. I don't think you can fit 2 rolls in there, but just one 1 kilogram roll will fit in there and seal up pretty well. So if you're having issues, or you want to, you've got some expensive filament that you don't want to get moisture in, there's others probably now. This was the only one a year ago, but now there are probably other brands of this also. But this one's an eSun brand. They're generally reputable company for printer filament and stuff like this. I just got it off Amazon though, and this will at least keep your filament sealed up. Some of the filaments that you might start printing, I mean, particularly if you do a mod like this over here where you're doing some of the higher temperature stuff, some of those filaments, first of all, they can be really expensive, like hundreds of dollars a kilogram for some of them, and they are typically very hygroscopic, where they will absorb moisture out of the air, and then they'll become brittle. They won't print very well, and that is a way that you can help mitigate against that embrittlement or the moisture coming into them. You can usually tell, now this yellow one does not behave this way, but you can usually tell if your print is, if your filament has too much moisture in it. One of the signs would be you print the thing out and it just has no layer adhesion. We might be able to deal with this by printing a little bit hotter and forcing it to weld together the layers better. Maybe we could do that. So that's one thing. Another thing that you'll notice if there's moisture in your filament is a lot of stringing. So there will be, you won't be able to adjust your retraction settings in any way that makes the stringing go away. And another thing that you can actually hear is while it's printing, you'll hear pops, kind of like Rice Krispies when you pour the milk on them. You'll hear that sound coming from the nozzle, and it's basically the moisture that's in the filament boiling off and exploding, more or less. So you'll hear those pops while it's printing. That happened on this material. So this is this was that high temperature. I don't know where the bag for it is right now. This is it. The high temperature PET. I showed it a while ago. It's not PETG. This is just PET. I think this is based on BPET. So a different additive into PET. And this, the whole time it was printing, there were pops and everything. You can kind of see like some surface quality issues here. You can see the changing color up here maybe. It does print really well. It's a strong material and kind of flexible, so it's durable. It does print really hot. So I had to print at 285, so you could not print that on a standard ender with the tube, the Bowden tube down in the hot end. It does have to be an all metal hot end. It's probably a little bit abrasive because it has some sort of glitter in it. But it was very, very moisture embrittled. Well, it didn't make it brittle though. It's not a brittle print, but the whole time the surface finish is really quite bad for what I would want it to be. It's not smooth at all. In a way that helps hide the layer lines, but it got some drooping problems over here. I still have a little left, so I did try to dry it a little bit in the dryer, but it didn't seem to have much effect on that. It did print fine. It was just bad surface quality. It does say off or low cooling. We're kind of at a weird angle there. Off or low cooling, and I was doing 50%, so I might try just no cooling. Hotter temperature, because it does seem to work better at hotter temperatures. They had a misprint on here. I don't know if you can see it or not, but they said that the bed had to be 275. That's or 270 to 285. That's definitely not true. I put it at 80, and that was fine. So printed that, and when the power went out, it reminded me of a print that I had not shown you. I showed the filament before, but this one was the blue glow in the dark. I think it's a PETG, or yeah, I think it's a PETG, and it started glowing whenever the lights went out. So I was like, oh yeah, I never showed y'all that one. I don't think I can actually show it glowing here. I can try to charge it, and you might can get a sense that it glows a little bit greenish. Maybe it's kind of hard to show on camera in the light. I don't know. I'd have to show it in the dark, and then it'd be hard to pick up. But it printed pretty well, and this one would print on a regular Ender 3. Ender 3s can do PETG. Just the one thing with printing PETG on a regular Ender 3, if you're printing up closer to 240, so some PETGs will print down at 220 or whatever, and that's fine. But if you're printing closer up to 240, it'll work. Just be sure after some time to check the end of your Bowden tube. So you would actually not have the direct drive here, but you'd have a Bowden tube. Pull it out and check the end of it, because you're getting really close to the temperature that the end of that Bowden tube might start to degrade on you. And if it does, then you chop it off and or put a new Bowden tube in, or chop that one off and just seat it down there again. You can't cut it too short because you do need the flexibility of being able to move your print head around. So if you cut this too short, then you've got problems. If you are messing with the Bowden tube a lot, it's probably worth getting some of these little clipper things. These usually come if you buy, this is Capricorn again, so if you buy a Capricorn Bowden tube, usually you can find one of the kits on Amazon that include one of these little guillotine chopper deals. I guess it's not quite guillotine, but it's a good way to cut the little Bowden tube. So this is a little remnant here. If you cut it with an X-Acto, so two things, or well, worse, if you cut it with these, then two things are going to happen. One, you may not cut it square, and so if I'm going to do an extreme version. If you cut it like this, wherever that went, so you have an extremely not square end. When you go to seat that into the hot end, you're going to end up with a big gap. And it doesn't have to be this bad. Just a slight gap will cause, since that Bowden tube is down where the filament is probably not molten, but really close to molten, it's above its glass transition temperature, it's going to ooze out of that gap and it's going to clog up on you. So that'll happen. The other thing, particularly if you use these, is that you're probably going to squish, yeah, you can see that. It's not a round circle anymore. It's an oval now because you pinched it together. And so if you're messing with these a lot or even somewhat regularly, go ahead and buy the kit that comes with one of these and chop them off. It's super sharp. It'll chop them off square. It's got a guide rail in there, or groove, so that you cut them square, and it just saves you a lot of problems later on. And these don't add that much cost to the well, let's just look and see. I don't want to tell you wrong. Let's see. So we'll just look Capricorn Bowden tubing. So, well, here's a whole thing with extra nozzles and heat socks and the couplers for $12. So, I mean, if you get just the tube, you might get more tube here, but it's $12. So just get one of the kits. You don't necessarily need the extra nozzles, but it never hurts to have the extra socks, and it certainly never hurts to have these extra couplers. But what you're really wanting is the tube and the little guillotine chopper, and it looks like about $12 for that. And I've got, I don't know how long I've had this one, and it's fine. You don't use them that much that they ever get dull or that they break or anything. So if you're messing with the Bowden tube, then I would recommend getting something like this. Also, this Capricorn tube is nice. It just has a tighter tolerance on the inner diameter, and so you don't get as much wiggling around of your filament in there, which can hurt retraction issues. All right, let's see. Is that all of the... Oh, no, here's one other thing. Printer's not on. Let me turn it on. So one of the things that I was concerned about on this new setup is the part cooling, and I'm still a little concerned about it, but let me show it to you. So I'm just getting things arranged. So let's, wrong way. There we go. I don't know how well you'll be able to see this or not, but so it uses the little part cooling fan that's on the side, and it directs some air here, and then some air goes around here and comes out on the other side. So it's a good idea. I don't know that this little fan has enough pressure to actually provide any air, particularly all the way across here. One way that you can kind of tell where your fans, if they're blowing air on your parts or not, you can look and see and try to predict where it might be coming out. But you can do a little water ripple test where you get a cup over here. Don't want to spill everywhere. get a little cup of water and just put it underneath the hot end, and lower the hot end a little bit, and then turn this fan on, and you'll be able to see if the water is even disturbed or not. You'll get an idea of just how much air are you getting flowing out across here. This fan is on already. This one is for cooling the heat sink, and you see that it's not really doing anything on the print, which is what you generally want. There are some printers that use this, not many, but there are some printers that use this fan to both cool the heatsink and the part. That's generally not a good setup. For one, you just don't have that much air. For another, some materials you don't want to cool the part, or at least not much. So most printers have one fan that's just cooling the heatsink, and another fan or two or three or whatever for cooling the part. So we have to turn this one on. Should be able to turn that on in the clipper. Let's see. Control, fan, print cooling fan. Just max it out. And you can, I don't know how well you can see, but I can see here that the effect of, well, what kind of water disturbance am I getting? It does look like the air from this fan, and it does look like it's coming out this side too, is directed directly underneath the nozzle. I'll try to get y'all closer to see where you can see something. I don't know. Well, I don't have a great angle. Let's see if we can reorient here. Yeah, you can kind of see. It shows up more in person. You can kind of see a couple of little ripples there. They're mostly covered by the rim of the glass I've got. But I can tell that there is air blowing right under the nozzle where I would have just laid new filament and for cooling. So it looks like it's at least workable. And I did print, this part that came all to pieces. I did print it, and it didn't have any cooling looking issues. It has lamination issues, but it printed no strings or anything like that. It's not really a part that would have strings though, the way it's made. So that is a thing you can do to try and gauge if you've printed out a new fan duct, or if you've got something. It's not quantitative at all. It's totally qualitative, but you can at least convince yourself that, yeah, I'm getting some air flow across there, or no, that is not working. And so you can at least get some idea of, is your part cooling effective, or at least is it going to look like it's effective or not. So we'll turn that off, and I'm going to move this before I spill it everywhere. All right, let's get it out of the way. All right, we'll put that back over there. All right, the other thing I was going to do last time is a little bit more on our mesh mixing, mesh manipulation. I have scanned this part a little bit. I haven't done a lot on it. I probably need to, I just did a little test scan. I think we're going to be able to make this part. There is an issue with it though, and it has nothing to do with being able to make it, make it the CAD model for it. I think the CAD model, what I'm planning on doing is I'm going to scan the top, bring that into, I'll probably do it in Fusion 360, because for mesh, I know those tools a little bit better than I know the SolidWorks mesh tools. So I'll probably bring it in there and then create this as a CAD body based on the mesh geometry, and then thicken it. And then I've taken a picture of this. This all pretty much exists in a plane. I'll just draw it as an extrusion, join those together, and we'll have everything except that little hook. That little hook right there. So the problem, modeling the hook's not a big deal. It's just a profile, you extrude it, and it's fine. So creating the model and even creating a print is not that big a deal. But making a print that's going to work, that'll be our little bit of a challenge, because we have to figure out, how is this hook down here, how is it going to print in a way to where it doesn't just snap off the first time you plug this thing into its socket? Because if you print this in any orientation where the layer lines are, where's it at? Layer lines are this way, that parallel to the end of this spatula, then it's just gonna, the first time you try to flex this thing, push on it to snap it in, it's just gonna break. So we could make it bigger. We could beef it up some to just have more. We could print it in a way where these layer lines are in this direction, so that you're flexing a layer versus flexing a whole strand of filament versus flexing across a layer and just snapping the layer apart. That's going to be a little bit challenging. Maybe we could print it standing up, I don't know, to make it do that. On the side would be a little bit of a problem because all of this is hollow in here, and remember, this is a light cover, so we can't just fill the whole inside solid. We'd have to remove whatever we put in there. So we'll have to figure out what orientation and how we want to redesign this clip so it still does its job, but it doesn't break the first time that we try to install it. So we'll get on to that. Probably not today. I might get a little bit of it to show you today, but I doubt we can build that whole thing today and do the other thing I want to do. So the other thing I want to do is I wanted to do not CAD modeling, but mesh mixing. So Thingiverse, Cults 3D, GrabCAD, printables, there are a lot of really large sites out there that have 3D models already made. So they already have STL models of a lot of things. Very few of those have CAD models. GrabCAD does. GrabCAD is different. It usually does have SolidWorks and that type of parametric model. Most of the other sites, though, just have tessellated geometry like STL files. And so those mesh files are really difficult to work with in your type of CAD that you've been doing with SolidWorks or Fusion or something like that. Now, if you're using software like Blender and ZBrush and those kind of software that are used to dealing with tessellated models, then yeah, go ahead and drop your files into there and manipulate them. But if you're trying to do something with these STL models to modify them, then it's gonna be a pretty long time learning curve in SolidWorks or Fusion 360. They can deal with them, but they're not made to deal with them. The difference is SolidWorks, CAD like SolidWorks, Onshape, Fusion 360, all of those CAD programs, they're built on the idea of parametric modeling, where one thing is you have this history of actions that you've taken, and you can go scroll back in history, change something, and then it'll propagate those changes forward. And so or you can have a parameter that controls some of your geometry. So if you want to change the thickness of everything that's labeled with that thickness variable can be changed at once. STL and OBJ files and mesh files, they don't have any of that. They are just a collection of all the vertices that create the geometry, the shell of the geometry. So they operate very differently, and even though SolidWorks and Fusion 360 can import them and can do some stuff with them, they're just not made for that. They can work with them, and you could probably get your way through there. I assume that over the next, 5 to 10 years or whatever, that process will get more and more streamlined. It's just that they're such different approaches that it's difficult currently without a lot of specialized knowledge and some specialized cases even sometimes. Sometimes the size of the models that you get from scan data just bog down the parametric modelers sometimes. In fact, I was working on Fusion 360 earlier, just an hour ago, and it locked up, just pure size of the model locked it up, and I had to restart. So what you do is, if you want to mess with your mesh and manipulate it in some way, and you're not too worried about like exact dimensions, you just want it to be a certain way, but you don't necessarily need a hole to be in a certain location or whatever. It's not like a part you're trying to make. It's just an object you're trying to make. One way you can do that, and we already used this piece of software, but you can use Meshmixer. I've got this little guy off of Thingiverse. So I went to Thingiverse and downloaded some models for us to play around with. I'm trying to remember which button combinations work in which. I can't get him to rotate the way I want him to rotate. We'll deal with that in a minute. All right. So this is just a guy off of Thingiverse, and I want to put him on a little scenic base. So it can be any combination of stuff that you want to arrange together. Meshmixer does have one like fatal, it's not fatal, but it's annoying problem in that if you put too many high polygon, so lots of triangles, lots of detailed models into it, then it will crash or lock up on you. So when you're using Meshmixer, then just be sure you're saving relatively often, because as your model gets more complicated, it will lock up and even sometimes completely shut down. So just save often so that you can go back to where you were. So this guy just came from Thingiverse. I also imported, let's see, I'm going to import, whenever you, in Meshmixer, whenever you click on the import button up here, you can either replace, so just take away whatever was there before, or you can append, keep what was there and add your new thing. I'm going to append, and all right, so this is what he is. He's a HeroQuest Famir. I don't know what all this is, but that was the name of the file. Then I've got this little small rock cluster. So here's what I'm going to use for his base. It came in not where I want it though, so we need to transform it. So let's, I've got the little rocks back here selected. I'm going to edit, transform, and I get a little gizmo for rotating it around and moving it, repositioning it wherever I think it looks best, scaling it. I can scale it to different sizes. I think maybe, where is, hold up, where is our base? Show the grid. Maybe there's the problem. Let's first, let's get him oriented with the base, because he's kind of weirdly oriented right now. So he looks better at that angle, it looks like. And then let's move him up on here a little bit. I don't remember, is it shift? One of these keys, it's snapping to the little grid here, and one of these keys that you can not have it snap. I'm not sure which one it is now. Alright, so he's getting close. He's a little tilted. There we go. So if you're okay with very like imprecise, oh, there's the snap down there, movements, then this will work for you. If you really want things exactly in dimensions, then this approach is not going to be what you want. But let's transform this, make it a little bigger. Something like that, maybe. We'll zoom out, and then let's get this guy more where we want him. Maybe we want him over here and facing this way. So you can, now I'm not paying attention to, is this printable? Like, am I going to need supports all over the place? I'm not even paying attention to that. Another approach is just print all the things out and glue them together. So that's a completely legitimate approach too, because I'm not at all considering printability right now. Speaking of that, one thing you can do with these is you can select one of them, and you've got a little analysis button over here, and you can do several things, including an orientation, which it will try to provide an optimum printing orientation, Sometimes you get good results. Sometimes most of the time you get kind of mediocre results. But it'll tell you this overhangs. It will show you everywhere it thinks, and you can, in this angle threshold, you can say, well, I'm okay with anything up to, my printer's fine with 50-degree overhangs. So you can tell it to select only 50-degree slopes or steeper. And it'll kind of tell you where you might have issues on saggy parts. And you could go in and manipulate things to deal with those, or you could know that you've got to have support in there or whatever. There is a generate support button. You could build in support to your part and in Meshmixer. So that used to be a really good approach. I think the slicers now, particularly with their tree supports, can do this relatively well on their own. Let's see what we get if we generate support. I didn't try that out, so let's see. See, it builds a little tree. Now it's connected everything to the floor, so that's a problem for us because we had him up off the floor. We could move our rocks down if we needed to, though. All right, I don't want that support on there. So let's get out of that and undo some of this stuff. There we go. Now we're back to where we were. So you can, and oh, the other thing in here is this inspector. You might have a model that has holes in it or anything like that, and this one does not indicate any problems anywhere, and you could repair them. If it has problems like a missing face or a hole or an inverted normal or anything like that, it'll point a little, it'll color it red and then bring in a little call out, and you can either repair them all or click on the individual ones you want to repair and it will repair them. And you have a couple of options on how it's going to repair them. The smooth fill is probably the better option. It defaults to flat. Just if it's a hole, it just covers it with a flat surface. That's just faster. So it kind of depends on what the error is, on which one makes the most sense there. And there's other options. You know, it'll predict if there's a weak part, if there's if it's not balanced. Basically, if its center of mass is not over its base, it'll predict that kind of thing. You've got some packing. You know, if you've got a multiple set of parts and you want to pack them into the smallest area, volume, I guess, it can do that. There is measure if you just are interested in the size of something, but that's usually not what you're doing there. So those are in the analysis button over here. Let's go back over here, and his feet are a little bit too, I don't want him floating, but that looks okay. Looks like his tail is embedded. That's all connected. So we've got him in place. We could go in, and I already showed you a little bit of the sculpting tools. I'm actually going to show you another thing here in a minute on the sculpting tools in a different piece of software that's in the web browser. But you could go and sculpt stuff if you wanted to. Maybe you want to sculpt the rocks or whatever. But you can take your two, let's get out of there. Get out of there. You can take your two, this object browser over here. It's kind of floating on the edge. I don't know how to move it for me. It's stuck over here. I don't know why it's trapped on the edge, but we can select the two pieces over there. So hold down shift and select your parts, and you've got a couple of options. Once you have two or more meshes selected, then this window just pops up on its own, and you can do a combine or a Boolean union so that they become one mesh. So I think I'll do the union right now. The union is going to might crash the piece of software. Actually, let's save. Let's just put that on the desktop somewhere, and he'll be here. There we go. So let's do the union and see what happens with the union. That was actually not too bad. So it's identified the two meshes. It'll try to figure out, is it going to simplify the meshes when it joins them together? I actually want the maximum quality, which might take us a while. I don't know. We'll click on that, and then we will accept it. And now we've got in our object browser, we only have the one mesh. Now it does show two groups here of different colors. That's fine. But now it's one thing. So if I export it as a STL, this is the STL all by itself. Then I could bring it in to my printer and print it. Now I do have issues like this hand is definitely not going to print in the way that it is right now. The rocks, everything. Some of his nose here looks like it's just hanging in midair, so that's going to be a problem. This area is going to need some support in it for sure. Everything else, probably some sagging there. These horns are kind of, they have points that are floating, so there are some issues on supports, but we can deal with that, or we can turn on supports, or whatever we want to do. We might go in Cura and look at that and see how that works. Let's just do one more. I have another little, let's see, these. All right, so these are gigantic. So let's edit, make those a good bit smaller. Put those over here. Now you'll notice one of them looks different. So all these hash marks, that usually is it telling the Meshmixer, telling me that this is a not printable, or at least it's the normals are flipped inward. So the surface normal, meaning you can kind of see a triangle right here. The normal vector that describes that triangle, which way's up basically, is pointing inwards instead of pointing outwards. We might be able to use our analysis tool. Well, we've got, it actually showed these as being issues. Let's repair those. Let's see if we can, I think there is a way to flip those normals. I'm just not remembering it right now. It will probably, most slicers will be fine with it because it doesn't care if it's pointing in or out. It may render it oddly like it's rendering here, but most of them will actually be okay with it. Let's see. Won't even let me really. Oh, look. See, that one made a really kind of odd mesh repair over there. So I'm going to undo that repair we did. I think this is just a bad model. We'd have to do some repair on the model that it can't actually figure out on its own. Let's re-bring it in. Let's re-import it and see. Yeah, so it's there when it's just got some issue down there that it's not too happy with. I want to leave it alone though, and I think this one will be fine. Let's make it quite a bit smaller and move it over here and just kind of sink it in there somewhere. Now it looks like he's looking at it, and then we can again go over here and select both of them, and we can union all that together. And we've got now notice the crystals got kind of lumpy. That has to do with over here on the how precise are we trying to make the resulting mesh, and I would like it to be a little more it's looking a little kind of lumpy, but I don't want to spend too much time working on it. We'll let it go. Oh wow, it really kind of lumped it all up there, and actually I think it put a hole in it. Still not happy with that. It's got some weird intersection up here, so that may not be a good model to join, looks like. Maybe we'll just get rid of it. We can find some other model if we really want to. But you can join stuff. Let's say that you want to do some additional sculpting on here. So you do have, oh, you do have these tools, and they're generally good. The problem with the sculpting tools in Meshmixer is that they can get really slow. And there is a piece of software that you might want to try. So let's go ahead and export our little guy here. And let's just call him something I can find. Let's see, combine. And we'll have a couple of options. We'll do the STL. There's an ASCII and a binary. There's a binary is usually a little bit smaller file. We'll use that one. There we go. So I'm going to close Meshmixer to make some space in my computer because it's getting kind of bogged down over here. And oh yeah, you've got there's some fusion. Oh no, that's the scan, Revo scan. Let's go to, where'd I put it? Here. So we need this. Well, so this is already brought one little guy in here, but this is here's the web address for it. I don't know what it's supposed to. I think it's supposed to be Stefan Engineer maybe, but you'll have to look at the address there. I'll put it in the description so you can find it, but it's Sculpt GL, SCULPT GL, and so it runs in your browser. I think there is a standalone thing you can download off of GitHub if you want to run locally, but it works pretty well in the browser. And this is it's meant for STL type geometry, so STL, OBJ, that kind of thing. You can probably import, a poly file, a STL, SGL, which I don't know what that is, and an OBJ. So you can import those file types. So we have STL, so that's good. And you can export those same file types. And it's meant for manipulating the mesh in a more like organic process. It's the sculpting tools like in Meshmixer, but they just work a little cleaner, and it's free. So you don't have to buy ZBrush or Mudbox or one of the higher end pieces of software that do a lot more, but they're probably I would try something like this first to see if you wanted to do that kind of stuff because the cost is high. Let's clear our scene. And let's import our little guy that we just combined together. There he is. And, well, he came in kind of sideways, so that's a little annoying. Let's see. I don't know if this... I don't know that I have an easy way to move him around. I mean, I can do this, but it's kind of limited on how far it can move. I think maybe this is an okay job for Meshmixer to, let's reorient him and then bring him in. So I'll go back to Meshmixer. He needs to flip forward 90 degrees, it looks like. So let's bring him back. Put him on the desktop, I think. And in here, he's on the ground, but that wasn't working for over there. So let's edit, transform, and let's just tilt him forward 90 degrees. And then we will re-export him. We'll just save over the top of what we already have. Okay. I'm not going to close Meshmixer this time, just in case we still need to do something. Alright, so now let's bring him back in. Alright, that we can work with. He's in the right orientation. So that's good. We'll close Meshmixer and get over here. Now, the cool thing with this kind of software, and again, this is kind of a really simplified version of something like ZBrush. You should play with it for one of these type of things for a little bit just to see what it's like and because it's a completely different mindset from parametric modeling in SolidWorks and Fusion 360s. Just so you know that there are different ways to create geometry. And so you've got 3 buttons over here. I actually never even messed with the rendering one before, but the rendering one is if I want to render a somewhat photorealistic scene out of this. Not really interested in that right now. Plus, it could take a while. Some rendering pieces of software are very computationally expensive, and so they can take quite a bit. I think this might just be talking about the in-window rendering, though, not an actual render. Let's see. Yeah, this is just in the window, so it's not that bad. We can kind of get some different material looks, so we'll leave that one alone. Topology is talking about, no, that's, oh, I see it's under my, let's go over here. So the render was up there. Whoops. Get over there. The render was up here at the top. Topology is right under that. So topology is talking about the actual triangles that make up the mesh here. Some of these will give you an idea of how many triangles are in here. I don't actually see that information here. Maybe it's somewhere embedded in one of these. I don't see it though. Usually you've got some idea of how many triangles you're dealing with, but one of the things you can do is you can take and increase or decrease the total number of triangles, so you can kind of make it an easier model to work with, so reducing the number of triangles, or you can make it a higher triangle count so that you can do more precise details, so you can like carve in little tiny details, but you'll need more triangles to do that. Or you can take just areas. Maybe you just want his face to have more details that you want to carve in yourself, and so you just select his face and subdivide, means take one triangle and divide it into multiple triangles. So a subdivision level of 1, I guess 2, would be one triangle becomes 2. And you can subdivide it over and over. Usually you can actually show the wireframe mesh. There it is, it's W. So right now if we hit W, you can kind of see he's got a lot of little triangles. There's the triangles that are making up the STL file. Not as much detail in the rocks, and so they've got bigger triangles. But those triangles are the STL file. And so you can kind of see if you want to add some detail in here, maybe make these ridges more precise, more crisp, then you probably need more triangles in there to manipulate to do that. So you could do something like, let's see, there's one button here. Yeah, control. If you hit the control key, notice my tool goes to masking. So I could color in. Now this is actually masking away, but we'll fix that in a second. So let's say that I want to work right here. And let's see. That's we can do that too. Okay. So I've kind of got that area masked off, but here is invert. So I can invert, and actually let's go back and color those. We don't actually want those in there. And so now I've isolated just his face here. And I can go to my little topology and I can subdivide that face. Let's zoom in to see what it does. And see, I've got more triangles in here. That was one click on the subdivide. And I could do that again if I wanted even more. Now at some point you're going to have so many triangles, you know, millions of triangles, that it's going to really bog down and it's going to be very laggy looking. So you can't do this infinitely. You know what? And it's even going to warn me. You see the pop-up there. It says, all right, if you do this again, you're going to have, and it finally tells me, and it's calling them faces. I've been calling them triangles. You're going to have be nearly 3 million faces to deal with. Are you sure you want to do that? If you know what you're doing, click subdivide. I'm going to leave that alone and not do that because that's probably overkill. Oh, did it subdivide the whole model? I wanted it to only subdivide what I had selected. So maybe it is subdividing the entire thing, which is not what I wanted. Did it subdivide? It didn't yeah, it's even subdividing the base. So it's not quite what I wanted it to do. Let's delete. Oh, I don't want to delete the lower. Delete lower would mean right now there are 2 resolution levels, and I could subdivide to create a whole bunch of triangles and then just get rid of the really low poly model. I don't want to do that. Let's delete the higher one. I actually wanted it to only work in the highlighted region, but didn't like to do that. Well, that's not exactly what I wanted to do, but what if we, it looked like it was okay with subdividing everything, so we'll do that for now. And maybe I'll look and see. Most of those pieces of software can deal with only subdividing certain locations, but this one is just, it's a free online tool, so it may not do exactly what I thought it would do, and that's okay. But now I've got these tools over here. Maybe I want to increase the creases, you know, in these. So now I've got the ability to come in there. On this button, I've got how much intensity do I want the crease. You know, maybe it was doing too much. It does have several undo layers. The other cool thing is if you have a system that you can use a pen on, then you have a lot more control. You know, you can go in there instead of having to use a mouse. It does work with a mouse. It's just easier if you can draw straight on the thing, you know, and you can come in there and really sharpen stuff. You can, maybe you want entirely new geometry, so instead of using the crease button, you could do maybe drag. So you could take this little piece and drag it out a little bit. That's a little bit sharp, but that's okay. We'll undo that. But now he's got some little horns on his nose. And that, you know, needs to be smooth. You can, that's a very aggressive smooth, but that's okay. But so you can do a lot of different things, and this software, well, I don't even know if it counts as software, but this on the this tool on Sculpt GL is pretty responsive. I find it's a little more responsive than Meshmixer. There is also, so the next level of this kind of workflow is ZBrush or Mudbox, and there's a couple of those kind of things. I believe ZBrush Core Mini. So ZBrush is a I don't know, it's been around 10, 15 years or something. It gets used in a lot of the CGI type stuff in movies and comics, all that kind of thing. Really high detailed games, creating the 3D models for high detailed CGI type stuff. So I was trying, yeah. So I think the ZBrush Core Mini is actually free, and so it gives you a good set of tools, use necessary, to create some model. You can kind of see the kind of details that they're putting into these models. It looks a lot like what we've got over here, but it is download software, so it does run locally on your computer, so it's dependent on what kind of specs you have on your computer to how well it performs. But I'm pretty sure the download is free for this. Yeah, so you have to register with Maxon, so that's a free register thing. That's fine. And then you can get a download link for the Core Mini, and it'll give you a few more tools than what you're getting over here. Actually, quite a bit more. It doesn't give you the whole suite of ZBrush tools, but it gives you a lot to work with to see if you like that sort of thing, and how it goes about working. You know, we could do, let's say we want to, let's clear our selection, and we've got a few little seconds here. Let's say we want to add, I don't know, let's add a band around his head. So, oops, I'm doing the wrong thing. I want to do this. So we can kind of trace out some pattern here, maybe a little larger than that. Not that large. That. Trace out some pattern we want to make. Like he's wearing a crown or something. We're not going to be too worried about what it looks like, but just how it works. Okay, and then we'll invert that selection. Now, it should be that we can just work on just this area. So we could maybe inflate just this, and that mask will, got a big lump there, will constrain where we're manipulating the geometry. Then we can smooth this shift, I think. Because that was kind of lumpy there. It looks okay. And then we can unmask, selecting outside, unmask. And then we could go to our crease tool. So you can see where a lot of little things could, you know, you could spend a lot of time working on making your own custom stuff. You can use this same process for completely from scratch, or you can, you know, do something like this. Take something existing and then add to it. One of the challenge for the course is to create a chess piece. It is totally fine to find a model that is sort of what you like, but it needs something changed about it to really fit the theme of our challenge. You could download that model and then edit it in a piece of software like this. You could edit it in SolidWorks Fusion 360. Probably most edits are going to be easier to do if the model is a STL file in Meshmixer or OpenGL. Oh, no, this is not OpenGL. This is SculptGL. And so you could do some stuff like that and create your little model, export him, export all, save as STL probably. Most of all of these files are all mesh files. Oh, the SGL is SculptGL's version of what their file is going to look like. The OBJs can also have texture, so if you have color information, like you've painted it digitally, then the OBJs will also have that built into them. But STL is just going to be the triangles. All right, so that kind of covers some of the stuff I planned on doing last time when the power went out, along with a couple of new things. I think next time what we'll do is, unless there's some comments on, oh, it says I was afraid that was the issue with my, the filament, probably. I just now saw the comment from probably a long time ago. Yes, the issue probably is, what I saw with yours, probably is moisture getting into that filament. The only ways to get the moisture out are to bake it out or to suck it out with desiccant. Other than that, or just get a new roll of filament. Sometimes if it's a tightly spooled roll, you can unroll a couple of the outer, like the outer layer, so you'll waste some filament, but the inner layers will not, of filament on the spool, will not have absorbed as much moisture. Sometimes. Sometimes it's kind of limited to the very outer loops of filament. Baking it out is really only an option if you have access to a low temperature oven of some sort that you don't really want to use for food. Like you already have, I don't know, you have some other thing that you have a oven. Now, if you have a dehydrator, like a food dehydrator, they're really good at pulling moisture out of filament too. But you still have the risk of like you're heating plastic inside the thing, and there might be some off-gassing that would taint the taste of food that you would later use in that same heater, oven, dehydrator. So I usually don't use the heating process. At school we do. We have some, temperature control or controlled ovens for heat treating type stuff that'll go down and hold and maintain a really low temperature, like 100 degrees Fahrenheit or whatever. And we can just leave them in there, and that's fine because you're not going to cook in those things. The other thing is just get a bucket of desiccant. You can get these bags. You can get bigger bags. You can get some desiccant that changes color. Yeah, this rechargeable stuff, that's a generally good idea, but the same problem comes up where you have to have an oven to recharge it in. So you have to bake out the moisture that's in that desiccant. So, and I've read there's a blue one and an orange one. There's the blue down there. You need to read up on those because the baking process of recharging the desiccant can also off-gas some stuff you don't want to be around. So you would end up with the same issue of needing some isolated oven that you could recharge the desiccant in. So it's usually better just to get the packs or the bag or whatever, get you a styrofoam ice chest, something that's going to be airtight. Drop your filament in there and a bag or two of desiccant and let it sit for a day. The good thing about these color changing ones is that when they change color, it means that they are full. They're not going to suck any more moisture out, so you know when to replace them. But the rechargeable part, you may not be able to take advantage of. So practically speaking, now you're at $14 here. A roll of filament is $20 or $15. So are you gaining anything? I don't know. You'd have to do the math on, can I get the value out of having the desiccant? You would be able to reach clear out more than one roll with one of these amounts of desiccant, so it might work. Did you say the last time that we could stick the film? I have never tried the microwave. It might work, but I've never tried the microwave. I've only ever used like a little heat treat oven on the heating side. I do know that you can use a dehydrator, like a food dehydrator, and the heat treat ovens. If you had a little toaster oven that you weren't cooking in, I just don't think I would use an oven or anything I was actually going to cook in later, because you're gonna get some kind of off-gassing from the filament or from the roll of the spool itself, and I just wouldn't trust that because I don't know what that off-gas would be, and it might not be. If you do it one time, maybe it doesn't make your oven smell forever, but if you did it often, then it probably is not a good thing. But I've never tried the microwave. Technically, microwaves do operate on the water molecules, so it might be that it can evaporate them. I just don't know. It vibrates them, but I don't know if it would evaporate them or not. So I haven't tried the microwave. Let's see. All right, I think that's probably good for today. Oh, what I was saying, next time, I think what we'll do most of next time is work on this guy, trying to get a CAD model that we can print. So it'll be a scan. I'm just going to take a picture of this as a profile, and then we got to figure out our little hook back here, how we're going to deal with that guy. And that's probably most of next time, unless there's some questions that have arisen between now and then. I think the printer over here is generally operating well. Other than the filament being very brittle, I think the printer itself is going fine. So I'll probably change out the filament and start printing some of the Rook 2020 parts on it, because I don't want to use that yellow filament if it's going to be brittle for all the parts. That would kind of be silly. All right, so I'll be back next time.